Well, we're going to start a new unit, and I normally put these questions up here for students to just spend a few moments kind of remembering some things about absolute value. So what do you think? I hope you're thinking about any of these four problems. That's what students would have done in class. So what do you got for number one? The absolute value of -4? Yeah, it's equal to 4, +4 if you want to be a little more specific, but the question is why? I hope you don't say because absolute value is always positive. That's a little bit of a cheesy answer. Remember, absolute value is a number's distance from 0. Oh, okay, so the distance from 0 of -4 is 4. How about this one? Can I do a distance, but still, and then do the opposite of that? Sure. So we end up with the opposite of that distance, the opposite of 4, or you can call it -4. So what if you have the absolute value of x is equal to 7? Now it's like we're looking for numbers that have a distance equal to 7. Numbers that have a distance equal to 7. Well, 7 is going to have a distance of 7, but so is -7. So we can end up with like two answers for x. Are there any numbers that have a distance that's -7? Well, no, because distance is always positive. So there's no solution to that supposed equation. Well, let's go to the sheet. Basically, the sheet, the absolute value sheet. We're going to talk a little bit about some equations, absolute value equations. But as a quick reminder, absolute value, remember, is always defined as a number's, that should be apostrophe, as a number's distance from 0. Absolute value is distance from 0. So if I have an equation of this form, just to show it one more time, it's kind of like we're looking for numbers that have a distance of 5. And yeah, 5 definitely does that, but so does -5. So you can see here, it's kind of like we're splitting the equation into a positive and a negative. That's exactly what we're doing, especially when we get in a more complicated equation. We can always isolate, and we can create two equations. One of them that's going to equal positive, and one of them that's going to equal negative. And you'll find out that we can have equations that are quite a bit more complicated than just the simple one over here, but the idea is still the same. We're going to equal a positive and a negative value. Now you're going to find out that there could be a problem with your answers, so we're going to want to check the solutions. We're going to check them because actually it could turn out that they might not actually be solutions. They might be what's called extraneous. Extraneous, that's just kind of a fancy word for it's an extra answer that's really not an answer, that it does not work. So, absolute value equations. Fun, fun, fun. Okay, we've got 3 times the absolute value of 2y plus 2 minus 2y equals y plus 3. Now, you can't just ignore these absolute value signs and do something like they're parentheses, like distribute. Can't do that. Instead, what you got to do is you got to isolate. Isolate means we want these absolute value of 2y plus 2 to be the only thing that's on one side of the equation. So there's some preliminary work that needs done here. And, well, that would start off by adding the 2y to the other side. That's going to give us 3y plus 3. And in this 3 that's out front, we're going to divide that. We're going to divide that. And now we have an absolute value of 2y plus 2 isolated. Also, it equals y plus 1. So, how do I interpret an absolute value equation? Well, I always interpret it being able to being a distance from 0, which means that the 2y plus 2 can equal the positive version of y plus 1. Basically, it's equal to the same thing. But the 2y plus 2 can also equal the negative version, the opposite of y minus 1. And so what just happened right here is the key thing in these equations. we set it equal to the positive and the negative. Okay, now keep in mind that it's still 2y plus 2. I did not change 2y plus 2. I didn't make that the opposite or the negative. No, it's what it's equal to. Okay, so look what I got. I got 2 equations. Yay! I got 2 equations that I can solve. And it's not too hard. You can do some basic algebra, subtract y, subtract 2. You know how to do that. And it turns out that you just get y equals negative 1. And then over here I can, of course, do some basic algebra, probably add y, and it turns out still subtract 2. Now when I add y, I get 3y, so I got a little extra step to do here, but that's just going to equal, oh, it ends up equaling the same answer. Now, it's just coincidence that it's the same answer, but the truth is, I still need to check these answers. What do I mean check? Well, you got to take negative 1, and you got to plug it back into the original equation. So we're going to plug negative 1 back in for all of these y's. Okay, I'd like to write this one out because I want to make sure that you understand what we mean by checking the answer. So here we go. We're going to plug in negative 1. We'll put it in blue. And we're plugging that in everywhere that we see y. And notice also that I'm going back to the original equation. I'm not going to go to one of my kind of like changed or simplified equations. All right, well, you kind of have like an order of operation that you would do here. Namely, you would deal with the numbers inside the parentheses. By the way, you end up with the absolute value of 0. Nothing wrong with that. Here, I'm going to multiply a couple negatives together, so that's going to get you positive 2. And over here, looks like it just equals 2. Now, the absolute value of 0 is 0. And I think we get to a point where we realize that 2 equals 2, that it checks. So negative 1 and the other negative 1 are definitely solutions to this equation. Sometimes I'll circle them. The truth is, if you don't do anything with them, in other words, if you don't cross them off or somehow say that they're extraneous, then I'm going to assume that they work. And again, in this problem, they do. Absolute value equation. You must isolate it. You must isolate it before you split it. Now, splitting it is the key idea, but I got to divide by 2 before I do any kind of positive negative split. And it's not a big deal. I get negative 3n over 2. We can deal with that. But it's time to write 2 equations. One of them is going to equal the positive. Now, when we say the equal to the positive, what we really mean is it equals the same thing. So it's still equal to negative 3n over 2. The other one though is going to equal the negative, or to say another way, the opposite. So the opposite, of course, is just positive 3n over 2. Okay, now if you're mainly worried about the fraction, we just kind of have to sort of get over it. You're still going to solve this equation by adding n. What you're really adding is a 1n. And when you add 1 to negative 3/2 of n, that's kind of like adding fractions that just give you negative 1/2 of n. Now in this situation, I can multiply both sides by negative 2 because I can multiply by the denominator. So I multiply both sides by negative 2 and I get negative 8. Over here, I'm still going to add 1n, but this time I'm adding it to a positive 3/2. So that's going to give you another full, it's like adding 1 to 3/2, and that comes out to be 5/2 of n. Now here I can multiply by the reciprocal since I have a numerator and a denominator, so I'll multiply both sides by 2/5. But if you multiply by the reciprocal, that cancels out. You also end up with 8/5. Not necessarily pretty, but it looks like it's the solution. Or is it? once again, you need to plug these back in to check. Now, if you plug in -8, it turns out that it does work. So I'm going to just circle that one. But I'd like to talk to you about plugging in 8/5. Now, it's not so much that it's a decimal or a fraction that's the problem. It's actually a problem because when I substitute it in, I end up with something that's not true. Let's make sure that you realize why. So I got to somehow take 4 minus 8/5. 4 minus 8/5. Now, you can do that with a common denominator. The common denominator should be 5, which is going to change the numerator to be 20. So if I go through that math, that's like 20 minus 8, that's 12/5. But it's the absolute value of 12/5, which remains as 12/5, which is going to come out to be 24/5. Now you could also turn that into a decimal. Off the top of my head, that's 4 point something. But the point is that we get 24/5. Look at this side of the equation. -3 times 8/5. You just multiply -3 times 8. That gives you -24/5. Wait a minute. I got 24/5 and -24/5. See, that's not good. That's not true. That's because this 8/5 answer is actually extraneous. It's not technically an answer. Again, it's not that it's a fraction, although that's not fun. The real problem is that it does not check when you plug it back in. And this is what can happen sometimes with absolute value problems. You can do all the right work, but you get an answer that's extraneous. Okay, not a big deal. Just cross it off, and maybe better yet, circle the other one to show that you checked both. Isolate the absolute value and then split it into a positive and a negative, or to say another way, split it into the same and the opposite. All right, why don't you try problem P1? Why don't you try practice 1 as something to see if you can get correct right now. Now, listen, you want to push pause and actually try problem P1. It's not going to do you a whole lot of good to just kind of watch me do it, although, yes, in about 10 seconds I am going to go over it so you can have that feedback. So push pause, see if you can isolate the absolute value, and then split this thing up into a positive and a negative. All right, so like we said, you do want to isolate the 2 plus 2n. Okay, that means that this 5 that's out here, okay, can't be out here. I can't do the problem when there are numbers that are around the absolute value. So we definitely want to subtract 5, showing the steps. That's going to leave you with pretty much the same thing now, just equaling -12. And then you do want to divide by -3. You're allowed to do that, and you have to do that. Now that finally gives you the absolute value isolated, which means that it's time to split this up. And we say split it up, we mean that you're going to split it into 2 equations, one of them equal to the positive, or the same thing, so it's going to equal 4, and the other one equal to the opposite, in this case, literally the opposite of 4, -4. All right, so you got 2 equations to solve. Do some good algebra. Subtract 2. Don't really have to show that, but subtract 2. It's just going to give you 2. Of course, if 2n equals 2, n equals 1. And then over here, same thing, subtract 2, except we're subtracting it with a -4, so that's actually going to become a -6, right? And then divide by 2, we get -3. You need to check these answers. Now, we need to check these answers. The truth is we don't 100% know if n equals 1 and n equals -3. In other words, if they really are the solutions until I plug them back in. Plug them back in where? Plug them back into the original equation. Yes, this takes a little bit of work. or do you want to, do the work? In other words, do what's necessary to make sure that you're right. I hope that you say yes. So we plug 1 back into the original equation, kind of follow the order of operations. Basically, that means that you're going to do what's inside those absolute value bars first. Basically, you get 2 plus 2 in there. That's going to be like the absolute value of 4. Now, as you keep working that out, the absolute value of 4 actually is 4. I'm going to show that because now I can officially say 3 times 4. Now, 3 times 4 is 12. 5 minus 12 is negative 7. So we can kind of put like a check mark on that. Better yet, go up here and circle this to sort of show that we checked it. What about this other one? Okay, well, you got to check it. You don't assume that if one works, the other one doesn't work. It could be the case that they both work. Could be the case that neither of them work. So we're going to do what it takes. We're going to plug in negative 3. Now remember, we're checking to see if it equals negative 7. Just don't lose track of that. Little order of operations, right? You do what's inside the absolute value bars. That's basically 2 and a negative 6, 2 minus 6. That's going to come out to be negative 4. In other words, the absolute value of negative 4. Now, the absolute value of negative 4 actually is just 4. So I can do the absolute value, but when I do that, then I change it to 4. So what do you think? 5 minus 12? Yeah, it comes out to 5 minus 12 again. That equals negative 7. That works. Okay, so yeah, it looks like both of these answers are for real. They're true answers. Again, I can circle them to kind of show that. And that's absolute value equations. Now, as a little bit of practice, there's a few things to try on the back here. Just be careful. These first couple problems, you're not solving them. You're just evaluating. You're just going to plug in the appropriate numbers and do a little order of operation. Get down here to this group, and yeah, we're solving equations. So now you want to feel like you're going to be splitting the equations. Now, of course, this one you can split right away because it's already isolated. Some of these other equations aren't isolated. There's some other numbers around them. So be careful. Make sure you isolate first. Then there's kind of an interesting problem at the bottom. See if you can figure out who's right, who's wrong, and perhaps why somebody's right and wrong. So we'll call that the homework, and we'll see you next time.